Hello, this is Dr. Adel Shabana, and we will continue our talk about Skill Lab ECG for Skill Lab, and today we'll talk about the ECG paper and the heart rate. So, the ECG paper is always divided into squares, horizontal lines, vertical lines, making like a grid, and this is dividing it into small boxes or small squares and big boxes or big squares. The horizontal lines denotes the duration of anything. So when we measure the number of squares horizontally, this means duration in millimeter duration in seconds. And vertically, this represents the voltage of the wave. So in each wave has a duration and a voltage. Okay. How can we calculate? Usually, the recorder of the ECG is in a standard speed of 25 millimeter per second. So every second is represented in 25 millimeters. This makes if each small square is 0.04 second, means 40 millisecond, and each large box is 0.2 second. Okay, so 5 large boxes are 1 second. So each small box is 0.04, which means 40 millisecond, 0.04 second. Each large box is 0.2 second, and each 5 large boxes are 1 second. And in order to calculate like this, you have to be sure that the recorder, the speed is 25 millimeter per second. Because if you change the speed, let's say we doubled the speed of the paper, instead of 25 millimeter per second into 50 millimeter per second, everything will be doubled, because now you represent each second in 50 millimeters, not in 25 millimeters. So the duration of everything will be double the normal. Okay, and this can be, sometimes we do change the speed of the paper on purpose, and sometimes it's a mistake, someone pressed on a button and changed it without noticing. So again, each small square horizontally is 0.02 second. The big square are 5 small squares, so they are 0.2 second. Vertically, each 1 millimeter is almost 0.1 millivolt, 1 to 1. We call it 1 to 1. Each 1 millimeter is 0.1 millivolt. So 10 millimeters will be 1 millivolt. So vertically we are checking the amplitude, and horizontally we are checking the duration or time. This is what I was saying, like if the same ECG, instead of making the speed 25, you made it 50, as if you are extending the ECG strip, because the second is represented in 50 millimeters instead of 25. So everything will be double in duration. Okay, for example, here between each two waves there is around 2 big squares. Here you will find it 4 big squares. Everything is double in duration because you made the speed 50. And vertically, as I said, each one is 0.1 millivolt. And this is one of the things which we have to check in the ECG, what we call calibration. Calibration means like this. This mark is present in the beginning of the ECG, any one of these shapes. The important is its amplitude, how many small squares it have. So normally you should find the 10 small squares. This mark is representing 1 millivolt. So what I want to check, 1 millivolt is how many squares. If 1 millivolt is 10 small squares, this is okay. This is the standard, to have 10 small squares representing 1 millivolt. If I find this one like half, like 5 only, so this means this is half calibration. If it is double, this is double calibration. So the first thing you have to check in the ECG before you comment on the ECG is the speed. Most of the ECGs, usually the speed is written, like here, 25 millimeter per second. And the calibration, either by, like here, times 1 means it is the normal calibration. If it is times 2 means the double calibration. Or you check the mark which is in the beginning of the ECG, you will find 10 small squares. how to determine the rate and the rhythm in the ECG. As we said, these waves are called R waves. Okay, so in order to know the rate, if the heart rate is regular, يعني first you check if it is regular or not. If it is regular and the spaces between each two waves are the same, then you calculate how many big squares are there. Let's say we will take this wave because it is on a thick line, then take another wave here. So the difference between these two waves are 3 big squares. 1, 2, 3. The heart rate is 300 divided by the number of big squares. So 3 over 300, 300 over 3 equal 100. So if between two R waves there is 3 big squares, the heart rate is 100 per minute. If there are only 2 big squares, then the heart rate is 300 over 2 is 150. If only 1 big square, it is 300. If 5 big squares, 300 over 5, which is 60. So on. So if the number of big squares between two waves is 1 square, only 1 big square, the heart rate is 300. If there are 2 big squares, heart rate is 150. 3 big squares, heart rate is 100. 4 big squares, 75. 5 big squares, 60. 6 big squares, 50. So you divide 300 over the number of big squares between two R waves. In this case, you have to be sure that the heart rate is regular. So what about if the heart rate is irregular? As we can see here, this space is not the same like this space, is not the same like this space. There is considerable difference. So we cannot which one we will take. We cannot be sure which one we will take to calculate. So what we will do, easy, we will try to find how many spaces or complexes in 6 seconds. Okay, and then if you multiply it by 10, it will be in 60 seconds, which is 1 minute. So to calculate heart rate, we have to calculate how many spaces or how many R waves or QRS complexes in 6 seconds. How can we get 6 seconds from the ECG? As we said, each small square is 0.04, each big square is 0.2. So 5 big squares are 1 second. So I need to get 30 big squares. So I will check in the ECG from the beginning, from 1, I will put a mark like this and try to count 30 big squares. Okay, so in these 30 big squares, you can calculate how many spaces in between. So 8, or calculate how many QRS complexes. It is nearly the same. Then multiply by 10. Okay, so again, you check the paper speed, you check the calibration, and then calculate the heart rate, as we said, by any one of these two methods. Thank you.